Hello everyone, welcome back to Jim's Garage. Today I'm taking you on the next step in our Homelab journey. I'll be discussing hardware choices and how you can start to self-host. Hopefully you'll see just how easy it is. This video will be split into two sections. I'll start by discussing what I call making use of what you have. Things like your laptop, PC, an old gaming rig, anything that you have still lying around basically. All of these are perfectly viable options, provided they have virtualization support, which is pretty much a given for anything manufactured within the past 10 years. If you're unsure, check your CPU and motherboard models and correlate them with the vendor's website. Make sure that they have features such as virtualization. You'll see things like VT-X, VT-D for Intel, and AMD-V for, yep, you guessed it, AMD. Next, I'll move on to detailing how you can purchase additional dedicated hardware, such as another consumer-grade PC or cheap single-board computer. You'll often see this abbreviated to SBC. Things such as a Raspberry Pi, that would be a good example of an SBC, and there are a whole host of other competitors out there in the market which would be a good fit. Finally, I'll discuss enterprise kit that you might be surprised to hear that you can pick up for pretty cheap via second-hand outlets like eBay, Hardware Buyer, etc., with the caveat of having to house it somewhere and keep the noise under control. I'll be making reference to this video throughout the series as we move on to more advanced features that will benefit from a more enterprise-like setup. However, you should be able to do pretty much all of it on a single device. So let's get on to it. Making use of what you have. The goal of this section is to outline hardware that will provide you with a cheap and readily available environment that you can begin with to familiarize yourself with self-hosting, set up and configure many of the basics, and be a solid foundation for what I'll move on to in upcoming videos. I recommend using a device with at least 4 CPU cores, 4 gigs of RAM, basically the more the better. Buy what you can afford. This will provide enough resources to facilitate the overheads associated with virtualization. Typically that's anywhere between sort of 2 to 5%. The core count should provide enough headroom to create a few virtual machines, especially if those cores are multi-threaded. You can often see that as hyper-threaded with Intel CPUs, and enough RAM to support them, especially if you're looking to do bare metal containers where you don't have the overhead of virtualization, specifically with a VM. So provided you have one of those items around, you're pretty much good to go with this series of videos. Right, so where do we go? On to dedicated. What I mean by dedicated is, a bit like I said in the past video, this is where you have a specific machine wholly dedicated to supporting your Homelab. This would be a device that sits separate from your daily driver, is intended to be on sort of 24/7, and something that you have another device that you don't need to touch that. So when looking to purchase a device, there are a number of things to consider. Let's have a quick recap. This is by no means exhaustive, but it's a good cheat sheet. First thing when buying a device, and we're kind of focusing on second-hand for now, is the age of the device. Now, the age of the device typically has a correlation with its power consumption. As chips go down in size in terms of sort of nanometers, chips are now more efficient today than they used to be, specifically on a performance per watt basis. The age of the device also impacts the likelihood of failure. The older it is, the more likely it's going to fail. I recommend personally going no further than sort of 5 or 6 years. I feel the trade-offs and the remaining lifespan of the device, they tend to fall off after this. Next consideration is expandability. So how much RAM can you fit? Typically in a consumer device, this is going to be limited to 64 gigs. You'll typically be able to fit 4 16 gig sticks. What's the maximum CPU that you can handle? This is typically limited by the chipset and what that particular family of chipsets supports. Typically it will be able to support 1 or 2, possibly 3 generations. AMD tend to fare better in this than Intel. You want to consider the number of PCIe lanes. So for consumer boards, that's pretty much 16 lanes, plus you get 4 that get routed through the chipset. Why is that important, you might ask? Well, it's important because things like a GPU, for example, take up 16 PCIe lanes, or some take up 8. What that means is if you plug in a GPU, you now have no other lanes left for other items, say SSDs, or maybe another graphics card. Maybe you want to put in a streaming card. Maybe you want to put in a host bus adapter, so you can put in additional hard drives, etc. What happens is each time you add a new device, you're basically bottlenecking it because you're having to push through more than 16 lanes through 16 lanes. So whilst that isn't really an issue for most of the videos I'm going to go through, because we're not going to be doing any sort of hardware pass-through, it is something to consider when you get onto more of an enterprise server setup, and I'll touch on that later in the video. I recommend something like an old i7 from something like the 7th generation, 8th generation. The benefits of that is it often comes with an integrated GPU. I'll touch on that later. Or perhaps an old Xeon from the sort of same era. Those do not come with a GPU and often require a workstation motherboard, but make sure that you check the compatibility of the motherboard and the CPU and make sure that those are compatible. Limitations of consumer grade gear that you need to know about: typically no out of band access, which means that there's nothing like IPME, which is a protocol for remotely connecting into your device. So things like you can monitor the BIOS and make changes externally. The device doesn't need to be sort of on, it can be in a kind of standby mode. This is really useful for when you want to do remote debugging, you want to do remote on and off switches, power cycles. You don't have to plug in things like a monitor, for example. They are limited, as I said, on the PCIe lanes, which is fine for the majority of the videos we're going to do, but can be problematic. There are a number of benefits actually to consumer grade devices. They're typically low power, certainly lower power than servers. They have fewer features on things like the motherboard and simply just their size, so it's easier to configure and understand, and you're probably already familiar with a sort of standard desktop setup. CPUs often have those integrated graphics, which reduces the requirement for that dedicated GPU. So as I mentioned before, you may not need those 16 lanes taken up by a GPU. And that's really useful because you can actually use the onboard GPU for things like video transcoding. So you may want to spin up something like a Plex server, a Jellyfin server, or anything that could benefit from hardware transcoding. With one of those consumer grade CPUs, you'll be able to pass that through as a device that the container or virtual machine can actually use. So in summary, let's look at some compelling options. So any Homelabber will have high regards around things like Intel NUCs. These are sort of small boxes, typically sort of a single board computer, but more akin to sort of a desktop environment. You'll get sort of the full Intel suite. It'll run a lot of the applications and native OSs that you're used to. Other options are thin clients, things like the Lenovo's, things that you'll often find are being replaced quite regularly in enterprises, and hence why they're quite readily available on eBay. Similarly, AMD also do NUCs, although they're not called NUCs, but they're effectively a small form factor PC. Now, I'm bringing these up because they're interesting and they're becoming significantly more viable and a great potential alternative to buying older hardware. Sort of since AMD's resurgence, the price per core has plummeted, and there's a lot to be argued for using a recent AMD Ryzen 3 5 CPU that can have up to 6 cores, 12 threads. Not only does this give you new hardware, so you kind of get rid of one of those negatives of dealing with 5 to 6 year old hardware, you also receive greater efficiency as these are built on smaller process nodes, so they're greatly more efficient performance per watt. AMDs as well typically tend to support ECC memory, which we'll cover later, but these are really useful for things like persistent storage, especially things like TrueNAS, for example, where the RAM actually has chips on it that are designed to correct and restore from data errors, so you don't get that sort of memory corruption. And they have more PCIe lanes, so 20 lanes and another 4 through the chipset, which gives you sort of 24 lanes. So I would recommend you look at both of the previously mentioned items, so weigh up how much it's going to cost you to get an old Intel setup or an old AMD versus actually splashing out on one of the newer platforms, albeit at sort of the more Ryzen 3, Ryzen 5 end, which are typically far cheaper. A notable mention, I mentioned it before, goes to the Raspberry Pi and other various spin-offs, the Banana Pi, Orange Pi, etc., if you can find them. These are ultra efficient. However, it's worth pointing out some of the limitations. They have limited expandability. Effectively, the RAM and CPU are soldered onto the board, so you can forget about changing any of those. There are options when you purchase them, but again, it's kind of fixed at the point of purchase. You can't change that again. And these chips are fundamentally different from the AMD and Intel ones we've been mentioning. These run the ARM extension set, and thus will only be viable for specific ARM images. Whilst you can put Windows 10 on and things like that, Windows 11, etc., it's not typically the same experience that you're going to be used to. So whilst some of the videos will work well, and people do indeed run whole Kubernetes clusters off Raspberry Pis, I think you just need to be mindful of what you can and cannot do with the Raspberry Pi in the future. Additional hardware that you might want to acquire at this stage would be something like a cheap managed switch that supports VLANs. Showed it in my previous video. Something like like one of the Netgear switches. Those are really good. Those kind of where I started. There are other competitors like TP-Link, for example, which pretty much do all the same stuff. So let's draw a line there and let's move on to enterprise gear. I'll be concentrating on the second-hand market due to the obvious concern of cost. Anyone who's ever looked at servers probably will be shocked to see some of the prices, often well into the 4 figures, if not 5 figures. And the second-hand enterprise market is practically littered with choices, as you can see from sort of a cursory glance on eBay. Can be quite overwhelming, so I'm going to give you a few tips and pointers. Much of what I've mentioned in the dedicated section still applies. So in summary, you want to make sure that it's not too old. You want to make sure things like probably the Intel Xeons, sort of version 3, 4 plus is kind of where I go. Preference for 4 plus, just it's a bit newer, it's a bit more performant, more cost effective, and just isn't quite as old. So the benefits that enterprise kit will give you, you're going to get that out of band access, which I was talking about, which one of the biggest benefits for me from moving from the consumer grade kit was having that. The ability to not have to keep plugging monitors in and out, to actually just be able to dial in from one computer to all of my network, just remotely configure it, do a remote reboot. Even when I'm out the house, I can kind of connect through my VPN and just do some administrative work, which is a lifesaver. Significantly more PCIe lanes, which kind of ticks that box for that future expansion. I'm running a Dell R730, which at the time I was buying it seemed to be a really good option, had a lot of the features I want. That comes with 40 PCIe lanes per socket, and I have 2 sockets, which is really good. Gives me everything I need. I'll go through sort of a rip down of what I've got in my server in a later video. You typically get a far higher core count and more RAM, and this is significantly cheaper when bought pre-assembled as opposed to buying sort of new RAM individually. I regularly see sort of servers on eBay with 128 gig RAM plus for the price of the server being under what you would actually pay for just the brand new RAM. So there are amazing cost savings to be had in that space. You often get a dedicated backplane for storage with high throughput. Typically these servers are designed to have fast storage attached to them. My Dell, for example, has 16 SSD slots on the front, so you could put in 16 drives with full throughput onto those. Typically come with multiple network interfaces, which is incredibly useful for segmenting your network traffic, reducing bottlenecks, improving security, improving performance. With a single network interface card, like on consumer boards or most consumer boards, all of your traffic is going to be going through that one NIC. So you can imagine that the more services and the more traffic you put through it, everything else is going to suffer as it's bottlenecked. And just as sort of a proof of concept, whilst I don't recommend doing this for sort of full reliability issues, I've managed to run my entire setup on a single enterprise server, my Dell. That was over 16 virtual machines, some of which have PCIe pass-through. I've got things like a Coral AI chip for image-based object detection for CCTV. Highly available firewall. Yes, I see the raised eyebrows. This is a single device. A gaming VM with GPU pass-through. Even a NAS with a whole host of drives pass-through. And a ton more of other stuff that I had on there at the time. Hopefully that illustrates the point as to what is possible with the right hardware. I'll show some options now that I think would be good based on what I've seen. So here we have the Raspberry Pi along with its technical specs. As you can see, quite a compelling little package. Comes in options of 2, 4 and 8 gigabytes. I think the 8 gig model goes sort of north of £100 or thereabouts, so quite expensive for what you get, but you are sort of paying for convenience. I guess the ubiquitous nature, there's a large support base out there, plus it's a very sort of small, neat and power efficient form factor. So back on eBay, looking again at a bargain hardware item. This time it's more sort of the consumer end, albeit it's more in a sort of a workstation chassis. You can see you can get sort of an i7 with 32 gigs of RAM for under £300. Now, if you do shop around, you're very likely to find sort of just the bare bones, i.e. the CPU, the RAM and the motherboard, perhaps without a case. You could probably get this more down sort of the £200 end. As you can see, this is my server. It's a 2U rack, which is a standard unit of measurement for sort of form factor. It has 2 processors. You have multiple options right at the low end from sort of 4 cores per socket all the way up to 22, which would give you sort of 44 physical cores and 88 threads. You can have up to a staggering 3 terabytes of RAM across 24 DIMM slots. You can have 7 PCIe 3 devices and a whole host of drives and RAIDs in the server as well, which will give you the option for sort of proper enterprise grade storage solutions. It also has a quad NIC, network interface card within the device, and dual power supplies, so it gives you that efficiency. One site I find really useful is labgopher. Now, labgopher is basically a crawler for eBay. You put in the parameters at the top, you use a sliding scale for what you're after, and it basically scours eBay for the latest deals that you might have. So for instance here, I've put in between £200 to £500, 0 to 2 CPUs. I leave the pass mark maxed out because there might be some outliers. So from here you can see that I've put £200 to £500, up to 2 CPUs. That's physical CPUs, not cores. I've left the CPU pass mark maxed out just in case anybody's got a real killer deal on there. The pass mark is effectively a way of measuring the performance of the device. There's a website for CPU pass mark, and you can go and see how all of the different CPUs tier up. As you can see from it very clearly, as CPUs improve, the performance improves. I've put up to 128 gigs of RAM because I think that's reasonable for the price range we're in. And storage similarly. A lot of storage you're going to get with older enterprise gear you might not want to use, just because typically it's been hammered and that's the reason they're selling it. Usually these devices are end of life, end of support, and you probably don't want to be relying on those old drives. There is a domain for a subdomain, sorry, for each of labgopher's sites. So if you're in the US, you can go to the .com website. Here I've got the UK dot. I'll put the link in the descriptions. But if you just go through these results, you can click on those. It'll take you to the corresponding eBay page, and then you can have a look through here. Okay, so to summarize, hopefully this video has given you an understanding of what is available to you when deciding how to start your journey. Any of the above are viable options and will enable you to follow most of what I'll be showcasing throughout this series. Key decisions really just come down to budget and storage. Servers are pretty big and pretty noisy. I might do a video on sort of reducing noise for servers at a later date. If it's of interest, let me know. So hopefully that was useful for you. Let me know what you think in the comments below. In the next video, we'll begin using our hardware. We'll start the first step in our journey and we'll create our first virtual machine. See you in the next video.